My name is Emilie Rouzies, and I'm a PhD student at the French National Institute for Research for Food, Agriculture and Environment. And in this presentation, I will present my results on sensitivity analysis to evaluate a new specialized process-oriented model of water and pesticide transfers at the catchment scale. And to begin with, I just would like to acknowledge all of my co-authors for the kind contribution to this work. So, to begin with, I would like to introduce Lamorcy catchment, which is an experimental catchment east of France that has been followed up by the team for more than 20 years. And this catchment is facing huge water quality problems due to an intensive use of pesticide for vine cultivation. So modeling could be an alternative to tackle such pesticide pollution, but when we want to simulate such landscape, the question is, what are we really dealing with? Because here you're facing a typical landscape from Lamorcy, and you can see that it is mainly composed of vineyard plots, but also a large range of linear elements such as rivers or vegetative filter zones, roads, that can have an influence and that can act as discontinuities in respect to water and pesticide transfers. So all of those elements has to be taken into account when modeling pesticide transfers. So this is one of the objectives of our team. It is to develop adapted modeling tool to tackle pesticide transfers and fate on small agricultural catchments. To do so, as I said, it's necessary to integrate the diversity of landscape elements. And it may also be interesting to explore different landscape management scenarios in order to find an optimal landscape organization in respect to pesticide mitigation. So for that, we have been developing for 3 years in the team the Pech-Melba model. This model allows for simulating heterogeneous landscapes composed of different elements such as plots, vegetative filter zones, hedges, ditches and rivers. It currently makes it possible to simulate water transfers on surface and subsurface, plus pesticide advection, adsorption and degradation. But so now just let's focus on the particular structure of this model, because the Pech-Melba model is composed of an ensemble of modules that stand for one process or one ensemble of processes on a landscape element. And all of these models can have different conceptualizations and different levels of complexity. And they are coupled within the open modeling framework, which turn the final application flexible enough to modify the landscape configuration, to add, to remove elements. So let me just resume the Pech-Melba modeling framework. Starting with the landscape, it is transformed into an irregular mesh composed of surface elements and linear elements, and different models that stand for different processes are then applied on each landscape element or each interface between them. So it results on a spatialized information on water volume, pesticide mass, and mass transfers between elements at different time steps. So to put it in a nutshell, the Pech-Melba structure is quite complex as it is composed of different models that are coupled and that interact. It is a really distinct approach from the classical 3D model that solve equation on a single domain, but that also make it complicated to modify the landscape configuration. And we also expect from that complex structure to lead to additional difficulties to diagnose the model behavior. But if we want to apply the Pech-Melba model, it is especially for operational purposes, it's necessary to quantify and to reduce the uncertainty associated with the model output variables. And this is the objective of my PhD work. And to do so, it's necessary to perform a global sensitivity analysis. And this is what I will present in this talk. With a focus on answering the following scientific and technical questions. First, which tools are suitable to address the question of global sensitivity analysis in a modular, specialized, complex model of pesticide transfers? And second, how can sensitivity analysis could be a tool to assess physical processes representation in Peshmerga model. So, to do so, we decided to start, as no sensitivity analysis has been performed before on Peshmerga, we decided to start by performing such analysis on a portion of La Morcie catchment, with the idea of being as representative as possible of the catchment in terms of slopes, in terms of elements, in terms of soil types or connection between the elements. So this is the portion we have chosen. It is composed of vineyard plots, vegetative filter zones in green, and a portion of rivers. And the scenario is characterized by three main soil types, each of them being composed of a succession of soil horizons with their own hydrodynamical properties. And we consider application of pesticide, which is a tibuconazole, on two upstream plots. So considering all of the soil parameters plus parameters relative to each landscape element types and parameters relative to pesticide, it led to 145 parameters to be sampled. And please note that parameters were not spatialized in the first approach to keep it more simple. But simulations are quite computationally costly. We were limited to a Latin hypercar sample of 4,000 points to be run in a reasonable time. So Peshmerga produces a large range of output variables, all mostly spatialized. And in this talk, I will focus on cumulated water lateral flow and cumulated pesticide lateral flow on each landscape element, as a high attention was paid during the model development to properly represent these processes. The sensitivity analysis methods that were used were firstly the well-known variance-based Sobol method, which aims at decomposing the output variance on conditional variances. And it must be noted that Sobol method requires a very large sample that cannot be computed in the case of the Peshmerga model, considering 145 parameters. So we used a polynomial chaos expansion meta-model method. This provides us with a surrogate method, but it also provides us directly with the Sobol indices, and that can be computed from the 4000 LHS. And in a second approach, we tested quite an innovative approach that was introduced by Sébastien Davega in 2015, which is based on the use of dependence measures in a sensitivity analysis context. The idea of the dependence measures is to describe the similarity between the distribution of the output and the distribution of the output given the input parameter x. If the distributions are close, it means that the parameter x is non-influential. And if the distributions are quite distinct, it means that the input parameter x is influential. And a lot of different dependence measures exist, and we focused on the Hilbert-Schmidt independence criterions, which is based on the use of space transformation and makes it possible to generalize the notion of covariance between two random variables. So the strategy was firstly to perform a screening step using the H6 dependence measures, and then to rank the remaining parameters using either the Sobol indices or the H6 dependence measures. And finally, last point of the methodology, even if the input parameters were not spatialized, Peshmerga still produces spatialized output variables, which mean a multidimensional output. And to scrutinize the sensitivity in this context, we chose two distinct approaches that were developed by Nathalie Saint-Jour in 2012. The first consists in performing sensitivity analysis as a local approach, which means that we perform as many analyses as landscape elements. And the resulting information can be aggregating on the form of map, giving the sensitivity of each landscape element. But if we want to have an aggregated information, we can also perform sensitivity analysis at the catchment scale in order to get to see the global influence of the input parameters on the multidimensional output, and this is called block sensitivity analysis. So let's move now to the results, starting with the screening step. So we started with 145 parameters, and we performed screening using a statistical test based on H-sig measure. For the case of cumulated water lateral flow, 84 parameters remained, and for pesticide lateral flow, 80 parameters. And then, after reducing the input parameter set, we can then perform the ranking using either Sobol indices or H-sig measure. So let's jump now to results regarding ranking, starting with Sobol indices in the case of water lateral flow. In this figure are the block sensitivity, on the left first order Sobol indices and total order Sobol indices on the right. So what we can see here that only four influential parameters remained, and they are mainly related in blue to the river, and they are characterizing processes of subsurface lateral transfers between the river and the water tables. And parameters in yellow, in green, are plot and vegetative filter zone parameter. This is the ponding height, which mainly characterizes the partitioning between vertical infiltration and surface runoff. But you can also note that first order and total order indices are exactly the same, which would mean that there are no interactions between the parameters. And those results are quite surprising considering the complex structure of Peshmelba. And the most probable explanation would be that the PCE, polynomial chaos expansion we performed, didn't manage to capture the interactions between the parameters, probably due to the structure of the model and to discontinuities in the model. So let's jump now to results regarding site sensitivity. You have here 4 maps that show the sensitivity on each landscape element for the 4 influential parameters. The redder it is, the more sensitivities. And those maps show us the interest of getting a deeper insight into local sensitivity, as it shows high spatial heterogeneities in influential parameters. So, for example, for ponding height on plots and vegetative filter zones, we can see that those parameters are influential on plots that are disconnected from the river, whereas parameters that are related to the river are mostly influential on plots that are connected to the rivers. And if we now compare to this result to the H-sig ranking we got, first for block sensitivity, you here on the left are the total order Sobol indices, and on the right the ranking from H-sig. We can see that the 2 rankings are matching pretty well, and that the H-sig measure is also able to capture additional parameters whose influence probably cannot be described by the Sobol method and by looking only at the variance, at the output variance. And same conclusion for site sensitivity. We see here the same spatial heterogeneity and the same patterns that for Sobol indices. With this, show all the interest of the method, and that even this method had been identified before as an appropriate tool for GSA, but it had been tested only on a few cases, and it seems to be also adapted to address GSA for the Peshmelba model, and the main interest being that this method is a low-cost method, and we don't need more than our 4,000 LHS sample. And finally, to conclude, let me give an overview of the pesticide lateral flow results. For the H-seq measure only in this case, and I will focus on site sensitivity on two distinct plots. The first one is situated upstream. It is disconnected from the river and it is a plot of pesticide application, while the second is connected to the river and it is situated downstream. So in this case, we can see that a higher diversity of parameters are influential, and all of those parameters are they characterize some distinct physical processes, and they show here that pesticide lateral transfers result from the interaction of various physical processes. So to conclude, in the study, we performed a global sensitivity analysis on a complex, spatialized, modular model with a complex structure, and we tried different methods. The Sobel indices appear to be hard to estimate on Pech-Melba model, but the H-seq measure appeared to be a consistent alternative for the sensitivity measure. And we show that a few parameters were identified as being influential, but that they had some high spatial heterogeneities. And last but not least, our Latin hyperpace sample also informed about output variables distribution that are mainly Gaussian or log normal. This is a valuable information for the next step of my PhD, which will be to perform data simulation on the model to reduce the uncertainty. So thank you for your attention, and I'm looking forward to answer to your question.
Okay, thank you very much, Emilie, for the presentation. Is there any question from the audience?
I maybe have a small question. I can see myself now. With respect to the Sobel indices, because it's rather particular that you had no interactions at all in the Sobel indices. And the problem was that I could not really see the actual values. What were the actual values for these four parameters? Because it's if this is correct, then it should add up to 1.
Yes, it is the case. Let me show it again. Share screen. So you can see yourself again. And let's go back to result. Yes, when we do the sum, it's
okay. Yeah, I see. Yeah.
So
and what was the reason that you thought that it was additive?
I imagine that I think it's not additive. I think this is miscalculation on Sobel indices were from the PCO, and I think the method to calculate the Sobel indices may not be adequate, because with the polynomial chaos expansion, we are making an approximation of our model with a sum of polynomial, which is continuous, which is quite regular. And considering the structure of Pech-Melba, I imagine that there are high discontinuities in the model that could not be captured by a sum of polynomial, the polynomial K expansion.
Okay. Yeah, I can see. Okay, thanks.